that in it. There we go. Share screen.
Cisco, at least the WebEx ball was kind of useful.
Never liked WebEx that much. I have to use Google Meet nowadays. Miss Teams.
You said
Yeah.
still better. Okay. So, hello everybody. My name is Daniel Belfry. I've been in networking for quite a while. My first computer was a Atari 800XL with a 300 baud modem. It wasn't the coupler type. It was just the normal, hook up an RJ11 cable to it. But I've always been interested in computing and communications. How do I move data from one computer to another? One of my first projects around the house was, I actually had several computers. Like, how do I move data from this computer to this computer without, going through without using a modem or a POTS line, right? And I basically looked at one of the things I figured out that all the computers at that time had a dedicated printer port. And I basically was able to, one of my little projects was basically electrically handshake signals between the two systems, and actually came up with one version of X modem, for those who knows that, and was able to move a binary from one system to another successfully. Before I figured out an all modem cable and other stuff, I reinvented the wheel, basically. So, yep, fun stuff. My background in college was in real-time operating. It was kind of a hybrid degree between computer science meets electrical engineering. So when I did go to college, not the first time, right after high school, it was a lot of hardcore EE and hardcore computer science, where write an operating system, build a computer from scratch, right? So when I look at networking equipment, I don't see a black box of death or a mystery box. I basically see something that I can hook an oscilloscope up to and basically figure out. I'm chasing ones and zeros. At the end of the day, I'm tracing code, right? I mean, it's no different. Timing may be a little bit off, but basically this stuff is pretty straightforward. But after well, I didn't actually finish college first time around. I went to a local startup ISP. A local entrepreneur contacted me, and he said he's going to start up an ISP. I'm like, wow, we've been trying to get a CompuServe node here in this town forever, right? We couldn't get anything there, so let's bring internet access to Southern Ohio. So that's where I officially got my start in networking, and that was customer number 0. And at the first location, we grew to around 75,000 subscribers in almost 35 cities. We were some of the first ISPs in Ohio, Kentucky, and West Virginia. I affectionately call us the slumlords of the internet. We would go anywhere where no one else would figure out, because it was very rural areas, and it was also very expensive. So it was, I could see that, places want to provide access to the top tier markets for the most profit, but fast forward time, I ended up at Oak Ridge National Lab in 2009. The system at that time was Jaguar, barely a petaflop system. And, I think at my peak, when I was from ZoomNet to Earthlink, we went from a mom and pop shop to a nationwide provider. I think we had around 1,000 locations. And basically I had about 30, maybe about 30, what was it, 25 or 30,000 pieces of network equipment across the country. Things were so, I had to learn automation, and I ended up being in charge of probably, we kind of carved the nation into regions, and I ended up with the place that had like 400 of those locations. So, and the worst places for tornadoes and bad storms. But fast forward time, like I said, it was so funny then. I mean, we had gigabit Ethernet connections. That was the thing, and that was 20 years ago. And nowadays, I mean, here we are at the lab, and when I started, we had 10 gig connections to the internet, and today we have hundreds. We're getting ready to go to multiple 400s. So yeah, things are always changing. And the theme behind this presentation is, how do you embrace that change? How do you, because it's constantly rotating, and we don't really shut the place down very often to do work. So that's the theme that I was going to talk about in this presentation. So, not to be confused, this presentation is not to be confused with the Supercomputing conference. Every November, it's a very big, Supercomputing is an amazing conference. I've only had a chance to go to it just once. And if you really want to see all the vendors, all the various technologies, it's very impressive. I would highly recommend it. I think next year's is going to be maybe in Atlanta, or honestly,
It's Denver.
Denver. That's right, Denver. So yeah. So the theme, I guess, the themes behind this, is how well do you know every piece of equipment in your network? Where are your bottlenecks? Everything has its limitations, and you have to think about these limitations in your design. You have to think about, do I buy the $1 million router, or do I buy 12 of the $50,000, or the $20,000 routers, or what's, where's the data traveling to in your data center? Where, as you come up with the design, everything has to be factored in. And like I said, everything is constantly changing. When one system comes in, another system's going, and the process is going out. We sometimes have multiple systems coming in. So sometimes you have to integrate and figure out. So you really can't anticipate where you're going to need the next amount of very large amount of bandwidth. So which brings me to a slide here. I got to readjust my volume here. Give me just, I'm not sure if I can do this.
Probably just want to play it right out your laptop for the sake of this.
Yeah.
It will kind of make it over to everyone else.
Yeah.
You can share audio as part of sharing your screen.
Okay, everyone look at what his suggested lists are,
Yeah.
and judge him.
That's fine.
Still on mute on YouTube.
Oh, yeah. I thought I hit it. Oh, there it is. There we go.
This is how Boeing does it, right? Except they outsource it.
Are they building the plane as it's flying?
Yeah.
Well, that's a,
Wait, is this what's known as a commercial?
well, Yeah, I saw this at one of our presentations a few years ago, and I thought that would be a little. I don't have a whole lot of humorous memes I was going to insert in this, but I thought that one is very accurate, because it's a constant dance of stuff changing. Turn my audio back off here. Okay, so HPC, how does HPC networking differ from other environments? We're typically, it's a mix of commodity, where you find that sweet spot of bleeding edge. Sometimes you have to go with that first generation stuff and make it work. Sometimes you might want to go with, and there's a trade-off to that. Because whenever you have to go to the initial stuff, basically you're not going to get the density. Something might be oversubscribed. I'll talk more about that here in a second. Well, I guess I could dive in that. Let's say, for example, you have a line card, and that line card has 10 100 gig ports. If that line card can only push 500 gigabits of bandwidth, you can only use 5 after you use the first 5 ports. You're basically going to start running into saturation. So those are the types of things you want to be thinking about. The other factor is scale, right? How many? If you look at your typical LAN, most places you're only going to have a couple hundred hosts on subnet, right? But sometimes there are cases where you might have 20,000, 30,000 hosts in a network. And what you have to think about that, well, gee, it's a lot of art. It's a lot of MAC address entries, right? So if you think about your entire network topology, if you need to carry that layer 2 somewhere through your network path. And I'll show an illustration of that here in a minute to try to kind of drive that point home. Bandwidth, latency needs. Everything in HPC is very much the requirement is pretty much maximum bandwidth as low latency as possible. Otherwise, a lot of the applications will just crap themselves. I mean, that's. Let's see. But yeah, when you have lots of nodes, you're going to start seeing scaling issues that you're not going to see in enterprise environments. When I mentioned, having, let's say you have 20,000 nodes, right? I mean, some of your commodity switches might only be able to handle, let's say 8,000 MAC addresses or 16. It's always a power of 2. It's funny how that works, right? Except in the case where it might be like 24K and you wonder where they came up with that number. But yeah, everything is usually in some power of 2. So requirements gathering. So the requirements gathering and design methods. It's a lot about asking what questions. The other thing is I'm a big user of checklists, and because you're always going to repeat the same thing just over and over again, right? Often we hear, I just want it to work, right? Sometimes you'll work in that environment where there's a lot of unknowns, and you kind of have to take your best guess based off of past experiences. So that, if the past couple systems did this, this is kind of what you want to do for the next system based off of, whatever you happen to be. So there's definitely some institutional knowledge there. An SLA would be nice, like, hey, well, I want to move 1 petabyte of data in 24 hours from this location to this location, right? But you really have to start peeling back that onion, right? What are the bottlenecks between those 2 points? What are the what's the speed of the server? I mean, you might have something that's bound by a certain speed of disk. You might be having something like have a server that may be it may have other, it may not be dedicated to this, right? So there's many points that can many things you have to consider. I kind of think of when it comes to these goals, think of the art of war, right? Know yourself and know your competition, right? You have to. But the other thing is, some people will do a top down, basically, or a bottom up design, right? And when I say that, it's you can throw the biggest piece of hardware at it and hope that it works. Or you could take it or flip it around and start looking at it from the applications. What do you know? And then start building that way to make sure that you understand that you now actually have the right hardware choice for the right location to meet those needs. So, but yeah, I'm a big fan of doing the trying to do it from the application side as opposed to just getting the best thing and hope that it works. I've seen cases where if you do that, sometimes it works, sometimes it doesn't, and that's experience there speaking. But there's also political aspects. There is sometimes there might be what is the staff capable of supporting, right? You always have to think of everybody being able to support some type of technology or some type of hardware. So, requirements gathering is, and what are the technical constraints, right? Sometimes, we don't often think about it, but let's say what are your logistics and communications processes if there's many teams in the same gear? Let's say, for example, at ORNL, we have shared access for like an IBM system. The IBM team has access to the IBM gear. but the Cray or HP folks have access to the Cray HPU. So, but not necessarily one group has access to the other. So you have to think about that type of thing. Like, how are you going to manage this from either like using dedicated passwords or radius, and make sure that someone doesn't, separation of powers, shall we say. So sometimes it's also inside of your organization. How do you handle that type of challenge? But there's also, what's the airflow like? What is the weight? That's one of the big problems that we have, that I've seen in some places. You grow, you realize someone's going to say, hey, this room, we can't put any more equipment over here, right? We've exceeded the capacity here. We can't put anything else. So it suddenly becomes a game of Tetris. Where can you put something heavy versus something light? Networking is basically wherever you have servers, you're going to have networking. And those are always the factors that have to come into play. I've also seen some network gear that, Mellanox specifically, liquid cooled, right? You're not going to have, that was for some of the bleeding edge InfiniBand at the time. Most of the stuff that we have is air cooled, but sometimes you will end up with something that is liquid cooled, and that induces other types of logistical challenges. But you also have to think about your distance. Are you talking 30 meters, 50 meters, 100 meters? Then you have to think about what's the RF like? If you're near any type of motors, or if you're near any type of like elevators or anything that can induce, or high voltages. We wouldn't have high voltages in a supercomputing center, right? So, there's places where you would want to run copper, and there's places where you would only want to run fiber. I guess is basically, but you have to know your environment. You have to know what. Sure.
So I've dealt with RF interference plenty, but how has EMI screwed you?
Me personally, never, because I've always been very mindful, and if I see a place where I would say we're only going to run fiber here, and we're not going to run copper here, so I can do it. I told you so.
All right. So 2 questions.
Yeah.
Can you translate EMI for most people?
Electromagnetic
Right.
high voltage.
And in a computing center, we have thousands of computers. Aren't you having a lot of, no matter what, noise just constantly slamming?
It's a matter of A, having the right proper shield of cables, but B, it's also the as long as you're not running those cables across the high voltage lines, it's a function of distance. The further you're away from those things, the better you are. So like your typical top of rack switch has things in the same cabinet. You're not going to have 400 volt or some megawatts of capacity in that cabinet, right? So the further you're away from that noise, the better. And in those types of instances, you're perfectly fine. I'm talking about, I wouldn't run like a 70-meter cable. If in my house, it'd be perfectly fine. But if you run that cable across, let's say you put it over top of the conduit that has the high voltage lines, good luck. It might work, but yeah, I wouldn't. Me personally, no. I've seen a lot of horror stories. It's enough that I've never wanted to chance that. If you go fiber, there's no problem. So yeah, that's something.
Except for those.
Yeah, well, we do have various types of rodents will chew into the power, and we do have power outages from that. I mean, it does happen, and they're usually extra crispy. Sometimes they'll even send pictures.
The place I worked at, a raccoon got into their substation, blew up. The substation, did about $10 million worth of damage.
Oh,
That raccoon, yeah, a nice little snack.
It was a little bit spicy, a little too spicy.
But on the topic of fiber, so your typical fiber is duplex, right? You receive on one strand, you transmit on the other. But in the past, I'd say maybe 10 years, there's been various forms of basically multiple bundles of fiber. And initially, when 100 gig came out, we had to use MPO 24. So there was 24. It didn't use all. I think it only used like 20. It's either 18 or 20 of the fibers, but it didn't use all of them, right? But the point is, some of these things require, especially like 400 gig, like they use for the short range stuff, they use a lot of fibers. And if any one of those fibers is pinched, it's damaged, whole house of cards comes tumbling down.
Sorry to interrupt again. I remember something called multi-mode fiber.
Mhm.
What is that
Okay.
difference and why don't you use it if it's better?
Okay, so it's a trade-off here, right? So you have two common types of fiber. You have single mode, which is your long range. You have multi-mode, which is your short range. The general rule of thumb is, and now there are variations with respect to how light optimized they are and how much distance you can squeeze out of it, but that's also a function of being sparks, not just it's also a function of how the speed, right? Like for example, 400 gig, you can even with OM4, you're only going to be able to get it to 100 meters. Typically with like 100 gig, you can get it to like 150 meters. So but 100 gig is now down to a BiDi, right? So I can use a single duplex fiber now but here's the thing, short range optics are dirt cheap. I mean, for 400 gig, I can buy a short range optic for $500, or I can buy a long range optic for $5,000. So, and if you, and that's list price. I mean, first generation, I wish I would have brought my optic goodie pack with me. It's optics that they just gave me, but it's optics that are obsolete. The first 100 gig optics that I ever had was probably like the size of a small personal pan pizza, and that single optic was $150,000. Yeah. So first generation is a very good example. First generation for long range, but here's the thing, that only use duplex, right? Singles receive and transmit, but that's.
What's the distance in the long range like? Clearly, you're still dealing with the same technology that ISPs are too.
It is 20 kilometers. 20 kilometers for single mode is the general rule of thumb. Now there's different flavors of that, and they can go down to different ranges, but without having a repeater in the middle to keep the signal at full strength, 20 kilometers is the general rule of thumb.
Yeah.
And if you were wondering, multi-mode is just an LED. Single mode will, that will cut you. Actually, you won't feel it as it damages your eye. I do know of some people, it happened a few years ago at a certain workplace, I'm not going to name the name, but a person did damage their eyes permanently from doing that. So,
Yeah. Look down the
yeah. And it's non-visible spectrum, so he should have known better, right? That's the training, but yeah. Anywho. So that was requirements gathering. So your typical new computer cluster. So we have to think about what is the type of nodes, what are the quantities, how are they connected, are they going to be internal facing, external facing? So to kind of dive into that, right? So typically when you have a new system come in, it's going to have some number of management nodes. These management nodes will manage some number of computes. Typically, it's going to be done in pairs for redundancy, but sometimes it'll also be for scaling. Like I've seen some systems. What was it? I think Summit has like 24 service nodes, right? The service nodes basically provision all the computes. So that's an example of a management server, and each management server manages a certain subset of so many thousands of systems. So when your typical system comes online, they don't boot off the disks, they boot off the network, and which is main reason there, less single points of failure. So there's one less piece of hardware that you have to swap out, right? But the other factor is, when I was saying internal versus external, we typically will have like a dedicated group of nodes called login nodes. Those are going to be your external facing world routable IP addresses. It's not possible to give, although the lab has several class Bs of public IP space, there's no way that they're going to give us, short of IPv6. Sorry, Michael, I did say it once. There's no way that we could give, public routable space to, 30,000 or 40,000 compute nodes. It's just not possible.
You should go still IPs for PC. They just have publicly routable networks. Class Bs.
The lab did too. Sure.
Yeah.
The lab IP on your laptop and it just works. Oh my.
There's a healthcare provider here in town that has a class B too. They run their own ISP.
Well, let me think. I can think of like all that.
Goodness, I have to pick up the pace. We're a half hour in.
Oh, no, you're fine. I think we're all doing this and.
So when we're talking about our networks, right, there's, how many, so let's say, how many nodes do you have? Let's say you've got 10,000 nodes. Well, when I was talking earlier about your MAC address and your ARP entries, right? Well, if you have, most servers will usually have a boot network, but they'll also have an IPMI network. The IPMI allows all the console, all the other external management functions, to allows you basically to reboot the box and do whatever from remote. So it's a very handy feature, but now you're talking about, let's say if you have 10,000 nodes, now you're talking about 20,000 IP addresses, 20,000 ARP entries. So again, when I was talking about the MAC entries, you have to be very mindful of that. Typically, your computes are going to have a low speed side that is connected to your management. Basically, that's where you get your operating system, and it's going to have a connection to the high speed side. The high speed side is where you're going to have InfiniBand or some type of high speed network that will allow you to connect to the center-wide file system, or basically allows the compute to talk to the other computes at very low latency. Which brings me to the next slide. So network buffers is a very interesting topic, and I'm almost, I'm not quite a third of the way through the presentation, halfway through time, so I'm going to cut through and try to save some time here. Yeah. So there is it's very much a holy war among the network and inside of the network community about what vendor. You've noticed, you probably never heard me mention a vendor name, right? You've never heard me, at least networking vendor, right? Whether it's Cisco, Juniper, Arista. I try to be agnostic, try to figure out which vendor works best for our needs, right? I mean, and that changes. I mean, it really depends on, they all have their advantages and disadvantages. But when it comes to the topic of buffering, and to put it in the most simple terms, imagine that you were looking at a graph, and let's say you have cacti or some form of where you're looking at the interfaces, and you start seeing discards, but you look at the graph, you don't see any peaks. There's no spikes at all, but you're dropping packets. Occasionally you might start seeing some applications like, what's going on here, right? I mean, the reality is when you do an SMB poll, you're only doing that every 3 minutes, 5 minutes, or some interval. What's really happening under the hood is when you have, let's say, several thousand nodes talking to something through a path, there's a phenomenon called microbursts, where you basically will have so many things talking to something at an instant in time. So if you were able to pull that data every millisecond, say you start rather than every 3 minutes or 5 minutes where you're pulling, you'd say, wow, you see this spike where your maximum bandwidth for like 3 or 4 milliseconds, right? Most applications will just, if they see a discard, TCP is just going to retransmit, right? Now, if it's a UDP based, it probably has a timer. We'll just try again, right? So network buffers, basically, it's a shock absorber. Whenever you have that big spike, it's going to basically disallow TCP to do its thing. So some vendors, I mean, it is a Goldilocks thing. You can't have too small a buffer. I've seen, and I'm not going to name the vendor, but I saw a vendor use a switch, had 40 gig interfaces that only had 64 kilobytes of buffer per port. Now, if you're talking about a 40 gigabit interface, think about how little of a buffer that is. Now, imagine pushing microburst traffic through that. That thing is just going to die. At the same time, if you have, let's say, a switch that has 8 gigabytes of buffers, well, it's not going to, even if you have something fast going to something slow, that's also going to create the same type of bottleneck, and you can't prevent that from happening. I mean, you're not going to squeeze a terabit of data through a 100 gig pipe. Again, if you need, a terabit, you need to provision some, you can't under provision. But buffers, in essence, is your shock absorber. The link that I provided here, the guy's name is Jim Warner, and he would go out and call out every vendor. And if the vendor, he would actually go and verify the data sheets. And if a vendor didn't put what they had in there, he would go out and verify it and post it publicly on that site. He passed away, unfortunately, sometime late last year, but yeah, I never got a chance to meet him, but he would call out all kinds of vendor shenanigans and post it publicly. I mean, it was, I really hope someone can pick up the mantle there because his information was invaluable on calling out problems. Sure.
His name is you.
Maybe it's a function of time and money, right? I don't mind. I don't mind. Doing evaluations, but that can be a bit of a problem, right? So in addition to buffers, there is there's a new methodology that's starting to be embraced by network providers. Basically, it's called intelligent buffering, and what they're doing is looking at they're categorizing your traffic in two manners. It's basically a mouse flow versus elephant flow. If you have an elephant flow, think of that as someone doing grid FTP or NFS or moving a very large TCP string for a very long period of time. Your mouse flow might be your LDAP, your DNS, something very transactional, very private, something that you don't want to just die. So basically what they're doing is if your buffers get full, it will say, hey, if this session's been going on for, let's say, greater than 500 milliseconds, I'm going to go ahead and selectively drop traffic to force them to throttle down so that the buffers do not get exhausted. It's like another layer of quality of service. Pretty impressive. I think that's probably where a lot of vendors are going to head to because the price of memory, when you start putting in 8 gigabytes or 16 gigabytes, or I mean, Cisco's new what's that called? I think it's called the Cisco One ASIC. It has a terabyte of RAM onto the ASIC, and it's reprogrammable. I mean, it's. I suspect that optic will that ASIC will probably be used in other vendors' hardware. But so limitations of the switches. It doesn't happen very often, but some switches barely support jumbo. So MTU, your standard MTU, maximum transferable unit, is 1,500 bytes, right? So in our environment or in HPC in general, rather than sending a single packet, many times to get the same amount of data, it makes more sense to get as much as you can in a single packet, right? So that's, in essence, that's why we use MTU. But the thing is, not all vendors will support MTU. And if you have, let's say that it supports an MTU of 9,000, well, what happens if you decide to carry trunking on there? And you do the basically, if you do the .1Q, if you do the 8211 trunking on top of that, you're going to have those few extra bytes of overhead. Now, unless you put those things in access mode, you're not going to be able to carry trunking across those ports. So, so MAC address, ARP entries, like you have to make sure that where you have a large number of servers or where you're going to be carrying that stuff, that it meets your needs. Buffers, you got to make sure that you have the ability to. You want to right size, find that Goldilocks point of not too much, not too little, just right, and it's both a sure.
Dumb off the wall question.
Sure.
A certain size of your environment, do you ever run into duplicate max?
I've
had it happen once.
I've never seen it happen at the lab. However, in past instances, I have, and that was basically where the hardware vendor was cloning everything repeatedly. That was a specialized appliance that was doing that. But even with the lab, I mean, realistically, here's the thing. I mean, even in not just the lab in general, I've seen people. The most common mistake is someone when they clone a VM, they're going to. That's where you run it. Or you're really going to run into someone cloning a VM and having the same MAC address stomp on in the same broadcast domain, right? My favorite is when someone takes the IP address of the gateway.
Gateway's gonna win.
Well, it all depends, right? So yeah.
Well, is it 2,000?
Awesome. One last question.
Sure.
Are you a fan of proxy ARP or do you hate it?
It has its purposes. It should not be used as a routing protocol. It has scaling issues, right? So I used proxy ARP very early in my ISP days. I basically would all the dial-up pools And I only did this for like /20, /22, /23, very small networks, right? And you're only talking like 500 hosts at most, where basically that pool would be announced to that local device, and that device would then announce that up to the router, right? I mean, but that's all just layer 2 broadcasts. I've seen places do that for /19, /17s, and wonder why their CPU is pegged from. So it's a matter really of knowing where the bottlenecks are, and that will only scale for so far. I mean, it's a handy tool. I mean, I wouldn't, but it's great for small deployments. I would not scale that, right? Because of the CPU function. It's a good question though. But yeah, everything, I mean, realistically, once you scale to those larger sizes, you really want to use a routing protocol and just have it announce it and not have to use, I mean, it's a bit of a kludge. The number and types of links, right? I mean, you know, do you have, you know, let's say you have 48 ports of 1 gig. Well, I mean, are your uplinks for 10 gig links? Or let's say you have 36 ports of 100 gig, and you have, let's say, you know, you have 8 100 gig links, or you have 8 400 gig links, right? You have to think about where are your points of oversubscription when you start thinking about your individual hardware. Same is true for your firewalls. I mean, the firewalls might only be able to have, I mean, they might be able to process 150 million sessions, but it might have a limitation of, say, of 16,000 or 32,000 MAC of ARP entries, right? So, you know, it's always a function of knowing your hardware. So limits of your routers. Yeah. So you know the limits of your routers. You have your OSPF BGP table size. I mean, local internal routing. I mean, I've seen OSPF tables. You know, just a handful of routes, and I've seen them with thousands of routes. It all depends on your design and your topology. BGP, on the other hand, I mean, if you have a global, if you have multiple global tables, you're going to make sure you have the adequate RAM to accommodate that. Sure.
You expand those abbreviations.
Sure. So OSPF is basically it's internal routing protocol, right? So it's open source path Dijkstra's algorithm, right? Border gateway protocol. Basically, BGP is how everything on the internet works. So it's everything is. I mean, when you talk BGP, that means you are some autonomous system talking to other autonomous systems. So let's say, for example, let's say that you have your own company, like, well, let's say the Labs AS. The Labs AS is number 50. My first AS when I registered was 11820. Sometimes these numbers will just be tattooed in your brain, like your first DNS server that you had to configure, you know, many times. But at that time, I think full routing table in the mid to late 90s was maybe, I don't know, a couple 100,000 routes. I mean, nowadays I think it is over 800,000, 900,000 entries. They try to get people to summarize down as much as possible, but you know, reality, that's not always possible. When someone has a class B and they hand it off to someone else somewhere else inside of the world, and they might announce it. But at BGP, your most specific route is usually going to be like a class C, a /24, right? In terms of IPv4 CIDR notation. So number of routing instances. I mean, you might have a case where you need many virtual routing for, basically, if you wanted to have multiple routing instance or a VRF, you might have a case where you don't want these routes to see these routes ever. It's like 2 completely different networks. 2 paths should not cross unless they go through some type of firewall or some type of common gateway somewhere. So that may, you know, also, and that kind of goes back to what are your requirements with respect to security policies and that type of thing. Let's see, access control list size. That's something I run into a lot. So we do layers of security, so we call security in depth, where you do a combination of access control lists, firewalls, IP tables. You know, you basically have layers of security, right? But realistically, routers are not firewalls, and you can most of them usually have a limit of like 4,000, 8,000, 16,000, always power to how that always works out, but of how big your access control list is. So your firewalls, oh yes, a topic dear to my heart. So firewalls, you have your type. Yeah, it's always about your speeds and feeds, right? So you might have a firewall that has 4 40 gig interfaces and some number of 10s or 25s, but you have to ask yourself, what is the maximum flow that this thing can accommodate? Like some pieces of hardware can only process like a 10 gig TCP stream. So you want to be aware of those caveats, right? I mean, if you have a 100 gig firewall, can you actually push 100 gigs to stream through here? I mean, let's say if you have multiple hundreds, what can it handle before it rolls over? And I tested this with many different vendors in the past, and I've actually found some vendors who actually underreported their hardware. I saw one vendor that they advertised no greater than 200 gigabits, and I pushed 280 gigabits of traffic through it before it rolled. So I was like, okay, I'm impressed. And you have to think about what's your total sessions. What is your sessions per second, right? And so say if you have someone going and like doing a wget or something, that's a single session, and that firewall will keep that session open until until the client or server tears the session down, and then. But you also have to think about what is your total throughput through the firewall, right? So, and outside of that, you also have to think about your objects, like how many objects can you have? Like an object might be, let's say this would be like DNS1, DNS2, DNS3. Then you could say, well, I want to have an object group called DNS servers that contains DNS1, DNS2, DNS3. How many of those can you have? But the nice thing about that is, once you have that, if you know what that limitation is, it allows you to embrace change easier. So let's say if you needed to make a change, rather than having to go and change all kinds of policies every time one of those changes, you just change that object, you just change the single entry in that object group, and it automatically updates all the policies associated with that. So that's tying back into the change. We're going to talk more about that here in just a second. The Science DMZ, this is the link that I provide here. If you can remember fasterdata.es.net, the Science DMZ is basically it is a method of a design best practice of how do you get your big data movers away from your firewalls and from all of the commodity firewalls. You want to have a friction-free path. Let's say, for example, if you have, and this goes to the concept of DTN, a data transfer node. A data transfer node will have a high-speed Ethernet connection, 100 gig or 40 gig, maybe even 10 gig. But it'll also have a connection back into the parallel file system, kind of like the computes. So basically, we have a certain, every big site out there will have a when I say site, I'm talking about DOE labs or other research facilities. They will have a dedicated system that's designed to move data from point A to point B. That's the whole purpose. And they're not meant for running compute on. They're basically meant to take, I'm going to move this, I've got a petabyte of data, I want to move it from this lab to this lab. And and this will go to how do you move that data? If you try to use SCP, good luck. You're only going to be throttled because that uses basically you're using SSH under the hood. Even with instrumented SSH, you're only going to get maybe 6 or 7 gigabits a second out of that. Sure, what's up?
What's instrumented SSH?
It's a modified form of SSH. Basically, normally, if you try to use SCP, you're only going to get maybe 1 or 2 gigabits out of it, maybe. It's not meant for high-speed transfers because of the overhead with the encryption. It will just fall flat on its face. But if you use the instrumented form of it, like I said, you can squeeze about 6 gigabits out of it. But if you're on a 40 gig or 100 gig node and you really want to move that data, you want to use an application called Globus. Globus, I think it's called Grid FTP. It's been around now for goodness, almost 15 years. It allows you to parallelize data movement. You're going to ask a question.
No.
Nope. Okay. But yeah, the DMZ is basically, this is where we put, like for our DMZs, where we have HPSS, this is where we have our DTNs, this is where we have all the big data movement that moves outside of, and the other rhyme and reason for this is if you want to put this as close to your border or to your edge of your internet connection as possible, you want to carry all that traffic through your network. It just doesn't make sense. And you just want to get that up to your cores or to your closer to your provider, get it off your network. That way you're not having to carry it through all the other places. It just makes sense. So yeah, I guess I stole my thunder there. You need to one thing that came to mind with respect to DMZs, we did a project a few years ago when we were moving out of one data center into another. Actually, I'll save that for the next thing. I want to make sure that I keep on time here. How are we doing? Oh goodness, I got less than 10 minutes to slam through this.
We still have a little time after this, as long as like everyone's fine with it.
Okay, so let me speed up things here just a little bit. Let's see. So I mentioned things are always coming in and going out, right? So just, it's the nature of the beast bringing in new technology. Knowing where your data is at in your data center. And now there's also concept, at least if many of you have heard the three-tier or the two-tier network design, right? It's basically you have your cores, distribution, your access layer. Some places might have a spine and leaf architecture where you basically have all your access layer connected up to, it's a two-tier. Some places might have a hybrid where they have what's called a collapsed core, where they might have different designs. It all depends on your scale, right? So when I go to some, so monitoring, basically you have to look at every data path. You have to look at your CPU. You have to look at your sessions. You always want to proactively look for errors, discards, and you can't take action. Well, discards are going to happen. I mean, it's just an accepted fact. What you really want to look for is what is your packet loss. If your total packet loss is greater than, let's say you discarded a million packets in a day. If that's less than 0.00001, don't worry about it. If you're approaching 0.01 or 0.1, you got a problem. So you want to be proactive, but don't when you see a big number, you may get a knee-jerk reaction. You have to really look into the data to see where that is. Not every tool is going to give you that, right? So if you poll, let's say when you do your typical S&P poll, that's only going to be done every 3 or 5 minutes, or you're not going to be able to poll hundreds of pieces of network equipment every millisecond. It's just not possible. But again, back to the overall thing, one I wanted to go over here was we're constantly replacing cores, distributions, firewalls, and access layer switches all the time. And basically, it's you have to embrace change. So I guess the meat of this presentation is how do you move, moving data centers. How do you move? How do you embrace these? How do you embrace this change without just driving yourself nuts or without taking large amounts of downtime? The first big data center move that I did was in 1999. We were moving from the 8th floor of one building down to the 5th floor. That was kind of a Hail Mary. We basically had to do once we moved the fiber and started rolling the server cabinets. I mean, it was a very staged operation. I think I was awake for 37 hours. Yes, I was chugging stems. That was one of the few times that I actually had to sleep at work for a few hours because I was, after 30 plus hours, you start hallucinating sometimes. But that's not always tenable, right? You cannot do that. Some places it might make sense where why don't they just stand something else up and migrate the data? If you have the money, if you have the time, if you have the facilities, it makes sense. It all depends on the environment. I mean, we had to move out of one data center at ORNL to another data center, and they had, was it 70 some petabytes of data? We ended up having to build like a 700 or 800 gigabit fabric and basically they did a transfer for like 3 or 4 days, moved all the data upstairs. Then they rolled the disks up. They were afraid that if they moved the disks, there's a chance that they could have lost the data. So basically they had the extra capacity just to be on the safe side, bring it up. So migrating cores. Okay, I'll have to shift it over here.
There's a little button.
Oh, what?
There we go. That's fine.
Minimize that.
There we go. Thank you. So typically, in this particular design here, we've got 2 core routers. You have some distributions. You have some DMZs. Your upstream router. You're basically, let's say we're going to bring in one of the replacements for a course. So you got to have your connection. Let's say I'm going to replace core 2. So I'm going to run a connection over here to core 1. It'll be a routed connection. You're going to have routed connections from here down to the new distributions, to the DMZs. Now, what we'll do typically is we'll bring this in, we'll set it up that we'll do the routing. At that point, we can no traffic will traverse through this because of your upstream connection is still hanging off of this particular connection. So basically, this allows us to fire up some servers and actually generate some tests from, like, for example, from here to here or from here to here. Stress test these links, make sure that you're not taking any errors. If everything looks good, you'll schedule a downtime, but it's not really a downtime. You're basically going to move this link from here over to here. Okay, we're going to let it burn in for a couple of days. Everything's fine. I mean, any traffic that was traversed happened to be traversed in this path. When we have multipath routing set up, it's just going to be a hitless failover. I mean, someone might see a packet or two drop if their traffic happened to be traversing at that instant in time. So this methodology, I call it kind of a leapfrog approach, basically allows you to, basically you're not really taking much of any outage here. And once you replace this one, you let it sit in for a couple of weeks. Okay, it's good. We're going to yank the old piece of hardware out. Now we're going to repeat the process for the other one. Rinse, repeat.
So you were talking about network vendor interoperability earlier. So say you went Fortinet to Arista on the routers. I'm assuming there's BIP on there. How are you able to share that and span it across the different vendors, or is there other trickery?
So in this case, I'm only doing layer 3 routing. So there's not really a virtual interface. Now, let's say, for example, down here at the distribution, let's say that I was running, if I was running like if I was running an SVI, right? I think it's referring to as a BIP here. It's a virtual interface, right? In network terms, that is a switch virtual interface. And there is a concept called VRRP. Basically allows you to have a high available address. That's the open standard. I think there's a Cisco proprietary one called HSRP. That allows you to be vendor agnostic. So as long as it supports that, you could have VIPs down here at your distribution or over here on your DMZs. This could be assisted. I mean, this might be a Cisco, this might be an Arista, this might be two different flavors of Juniper or something else, right? You don't, as long as it's open standard, doesn't matter.
Okay. So you're saying that I was gonna ask that question. So are open standards now the protocol? I hate to say it that way.
I would never get into a vendor proprietary solution.
What, you don't like EIGRIP?
Actually, it's a very nice routing protocol. It's actually better than OSPF. It can do so much more. The problem is, if Cisco would have released that 15 years ago, before they actually did, they kind of kept it. I mean, I know why they did it, right? But that's, yeah. So migrating distributions. It's very similar to the cores, right? I mean, you're basically going to have, you're going to have some layer 3 connectivity from the switches up, and you're going to have a layer 2 path from this pair to this pair, and basically you're going to have switches that connected over it. So you're going to have switches that connect to these. So you're just going to swing them over. And now, when you swing these switches over, basically you would let's say for example, you shut this link here, and then you would run this cable, but you keep it in a down state. Now you're running exclusively off this leg here. Now, as quickly as, when you're ready to do the actual cutover, this is where you might take a second or two hit. Basically, as quickly as you can shut this interface down and bring this interface up, that traffic is just going to start flowing this direction. If things are good, you can go ahead and repeat the process. You can go ahead and shut this link down, move it over to the other one, and do your math. What I didn't show here in this illustration was the layer 2 connections from these to these. It would have just been ugly in this particular diagram.
So when you're, as far as like physical, sorry for all the questions, but as far as physically having the links, considering how often you're migrating, are you physically sitting there leaving spare fiber and spare Ethernet for new migrations? Or are you running it on demand?
So the connections that I would have from this switch. Now we do have
The red ones in specific.
Yeah, so this would actually be in some cases, we will swing them. Some cases we'll run new. It depends. It depends on how close they are. If it makes sense to swing them physically, we will, because if you can do so cleanly without having a rat's nest of cabling. Otherwise, if it makes sense, run new cables, run new cables. Yes.
I think he's asking, do you leave network ports
Yeah.
for switching over? Or do you allocate, or you take an existing working one, turn it off and reallocate it for?
Like, for example, 8 pairs of fiber. Do you just leave 50% unused for migrations?
No. So when we bring in the new hardware, it's going to have just its basic upgrades. Now, when it comes time for this to come out and it's now over on this side, basically, it's kind of like a flip-flop, right? I mean, you could be at 80–90% capacity and then bring the new hardware in and just migrate it over. You don't necessarily have to be at 50%, right? It's just a function of time. And the downside is if you're in the middle of this migration, or if you've not started this migration, you don't want to make sure that you've exhausted. You always want to make sure you always have excess capacity. In this context, you can have many different pairs of distributions. So it's about scalability. You might have many pairs of these where you're carrying stuff down to many different layers of access switches. Firewalls, similar process. I mean, basically, there's many different types of firewall deployment models. I mean, I was using this particular model here is what's called a router on the stick model, where basically it's basically doing all this routing through a layer 2 path. If you think about if you think about a multi-layer switch and you have a server and you basically have, let's say, 5 networks on there, if you have a router and then you're bringing that down to 5 different VLANs on a switch down below that, and they're all going through the same path, and the routing for those basically go up and back down, right? So that's what that concept is. But with respect to the firewalls themselves, this particular illustration is assuming an active passive. So you would stand up your new firewall pairs, and basically, if you have the design correctly, where you have it kind of goes back to the switch where you're moving fibers, except in this case you're doing as quickly as you can do a shut and a no shut. You're basically going to shut the SVIs down here. You're going to no shut them here, but when you do that, firewall pairs, typically you're not going to keep the state. So it means all your applications will take a hit. But if you do that on individual networks, you always want to do that toe in water approach to make sure everything is good, extra failover, all that stuff. It just works. When you start doing these things in patterns, and it allows you to manage the chaos of all the constant changes. Because you might say, hey, we need this. You may not necessarily know that we need to move 800 gigabits from this point to this point. Well, if you set your DMZ up correctly and have enough free ports to allow for, when you mention keeping free ports, yeah, I always keep extra capacity, because that is, that comes in very, very handy. So going forward, so vendors will lie. They will, or they will give half truths, right? It's not necessarily, or they may not give the information, but there's a lot of free sites out there. But do your own evaluation. Many vendors, if they want the sale, they're going to figure out what works for your environment or what doesn't work for your environment. So with this particular design here, let's say you have some access layer switches here. You wouldn't want to carry 20,000. Let's say these switches here were only capable of, let's say, 64,000 MAC addresses, right? Well, if you have a bunch of switches down here, downstream, if let's say you had 30,000 hosts here and 30,000 hosts here, you couldn't carry that through your distribution network, right? You're going to have to create these little silos and just make sure that you don't care. You have to be mindful of where you carry that traffic. So something to keep in mind, or you'll box yourself into a corner. So you kind of have to have some of these, shall we say, silos of the data. Let's see here. Oh yeah. So some other things that you want to really ask vendors for is, I mean, no vendor is going to be perfect, right? I mean, there's always going to be bugs with your OSPF or LACP or with HA failover or with SNMP, you know. So it's always an opportunity. You always want to verify as much to your environment as possible. I mean, I will go to the extent of like pulling out a power supply, verify that the Nagios check works, make sure that pull out a fan tray, make sure that I pull out a line card, that all of my monitoring works as expected. So it's having some of these processes basically helps keep you sane and helps keep the when you have processes and you have a repeatable process that you can share with your team, suddenly it makes some of the things not so scary. Because if you're talking about upgrading everything in the data center, like, wow, that's, but when you really think about it, if you break this down in terms of, hey, I want to move little bits and pieces, right? You want to do things incremental as opposed to a forklift approach, right? That 18 or 36 hour downtime, you try to avoid that if you can, because there's a point that you're going to reach this, there's no going back, or it's very painful. I love the ability to, hey, if something didn't go right, no shut, right? I mean, it's that's you always want to do things in incremental. That way, we're not taking the center down, right? There's only the only times that we really impact the center is if we move a switch that carries our NFS servers or impacts the NFS servers. NFS is a very poorly written application, and if NFS is unavailable for more than a few seconds, every server in the data center will go and will require a Vulcan nerve pinch to recover.
I believe that NFS is a perfect protocol, and that it's just the networking that fails to adapt to its uniqueness.
That is why we try to keep very low network availability, but sometimes it does happen. I actually caused the last outage at work. That last outage in our network was it April or March of 2021?
Full outage or like partial?
It was partial. But basically, it was a unplanned downtime, and it was a code upgrade that I did everything proper, did everything, followed all the right procedures. The vendor in question basically said, whenever you have, if you're familiar with the concept of MLAG or virtual port channel, normally you can do that hitless, right? But there are certain vendors who do not play nice, and I won't name names, but basically, if you follow in past instances, if you follow their code rev and you have to do an incremental. Let's say I want to go to 5.1 to 5.2. You might have to do 5 or 6 upgrades to get to your final thing. But as long as you followed that, it would just work. In this case, it blew up on me, and it basically, the network was down maybe 10 seconds, but that was enough for the NFS servers to die. Everything froze. Everything, so that's
We'll say this is far more resilient.
Yes. Yeah.
Fair enough. Fair enough. Sure.
So there used to be a lot of, I don't want to call it off-brand because they were on-brand. And my grade is going to show MirrorNet.
Okay.
Weird, very specialized pieces of network equipment. And I remember the MirrorNet network cables for the time were 3 centimeters wide.
Yes, I remember those.
Is there vendors like that are still out there that would be useful for an HPC community?
oddball, but it's so fast.
It depends. So that is up to the server folks. I mean, that's more of the HPC team and what they, or the clusters team, and what they need with respect to their computes, talking to their computes. Kind of goes back to the application needs, right? I'll be honest with you, a lot of places are moving away from InfiniBand and moving towards Ethernet. Ethernet is getting to be exponentially cheaper, the higher speeds, lower latency. The proprietary stuff, I'm sure it has its niche, but if someone's going to have to come in with something that just blows it out of the water, or if it scales really well, right? I mean, call it slingshot on steroids, right?
It's always gonna be wireless.
Yeah,
If it's gonna be wireless, please let me know. I'll come beta test it.
yeah. But that is everything. I apologize for going a little late there, but
No apologies.
I tried to.
That was much better than.
That was much better than me yapping about these.
Thank you. I very rarely have to think this low level. I appreciate the opportunity. One to ask, in your experience, what has been the least advisable network configuration that you had to implement because of a project concern?
Oh goodness, let me count the ways.
And I want to rule out supercomputers,
Oh, well.
just because those are always weird.
So when I worked at an ISP, you always had to make do with stuff, what you had, right? So it's always, I mean, today we call it tech debt. But realistically, there's no difference in networking, right? You might have to put something in that may be suboptimal. You might not have enough ports for, let's say, your uplinks, right? You might have some form of oversubscription. I mean, you just have to accept it and make sure that communicate, document it. I'm not necessarily proud of it, but sometimes you just have to do that, right? I mean, and redundancy, it's also a function of redundancy. I mean, realistically, I mean, our network is designed, and I try to do this. There's enough redundancy that I can yank out half the network and no one would notice. They might, I mean, no one realistically, unless they're doing a high stress test and moving something, no. So but you can't do that for everything, right? You can't do that down to every single access layer host. But if you do that for your critical services, for your NetApps, for your ESX servers that run your LDAP and your DNS for your whole center, guess what? It just works.
So I'm hearing suggestions on how to do it the right way.
Okay.
I'm looking for what was out in this situation which you had to do it the wrong way
When did you go to Walmart and buy a Switch?
because of concern of your price.
Oh, no. Okay. So let's say, okay, doing it the wrong way. I had to buy unmanaged hardware, and you just have to accept the fact that you can't manage it. Okay. I'll still sleep good at night, but in fact, a lot of even at my old ISP, there were some devices that I had out there unmanaged, right? I mean, it is work. But it was just an extra layer. You have to accept the fact that if something breaks at 3 o'clock in the morning, someone's going to have to drive out there and fix it. And it might just be someone that had to move a simple thing where if they would have had to make something managed, hey, but no, if there are cases, Caleb, I'll be honest with you, I honestly don't remember. It's been, I've had so many little instances of things like that. It's just like water off of a duck's back. Really. I mean, I don't worry about those types of things anymore, because otherwise it will stress you to death. It really will. Sure. Oh yeah, I think.
I want to see if anyone remote wants to go, so we're kind of hogging. Is there anyone remote that wants to ask a question?
Can you escape out and we hear them if they talk?
Yes, we can.
Escape out and see faces.
Oh, hey, Jerry's on. I had no idea, actually. Jerry, is you or someone in your class? I guess literally no one wants to talk to us.
And everyone is muted just in case we're doing that regular Teams thing.
No class this week. Starts in a couple of weeks.
Oh, okay.
So this is a weird question. How often, 1500 is, sort of like that old school, let's keep it this way. How often is the actual issue? Oh gosh, it's jumbo frames.
Oh.
That's like,
Yeah,
on our
I'm-
little
I'm-
stack, it's SE Linux and Jumbo frames with it.
No, you're absolutely right. If someone forgets to configure, now, most Cisco devices, at least the older Nexus line, it was a global config. You set it globally, you didn't have to worry about it. But they've gone back to some vendors now have to do it per port. If someone misses that port configuration, it's best practices, right? You just, but it's easy to figure out. Do a jumbo ping, don't fragment.
So, we're talking about the future, we're talking about configuration, software-defined networking. Is it in your environment, or are you basically doing, I know it's like, we don't make many changes. We're gonna do it I don't wanna call it old-fashioned, because old-fashioned often works correctly.
So SDN has been around for a very long time. And the first iterations of it, it was great for an R&D and a dev environment. Fast forward to today, SDN actually has a place. It actually has the right amount of redundancy. I'm actually looking at setting up. So I've got 2 test beds that I've been working on. One of them is VXLAN. One of them is where I've been playing around with Ansible, where I can basically verify my stuff and make sure I don't implode stuff. SDN is on my to-do list of play around with. I can't remember the name of it off the top of my head, but I was thinking about doing that with a combination of some open source routers and just kind of play around with it in a virtual environment to see how I can do the configurations of, say, hey, we got a little hotspot here. I want to redirect traffic or dynamically reprovision parts of the network. I've been thinking about that, and I've also been thinking about how I can better manage some of this chaos. One of the other problems that we run into is lack of fiber in certain places. So what I've been thinking about is why not let's go for the, if you ever read the book, Project Hail Mary, right? But going for it is go for the long. Think of that long term. I've been thinking about getting some fiber multiplexers and basically going out and dynamically. If I could actually dynamically say, hey, I'm going to take this fiber, I'm going to split this, and I'm going to turn it into 20 or 30 fiber pairs, as opposed to multiplexing. Basically, you take one pair and you can break it. You can basically say, let's say I take one fiber pair, I can turn this into 10. Got a path of 1, 10, so I can kind of swing through that path. If I could leverage that type of technology on top of the SDN, I could dynamically figure out. I basically use the software to say, hey, I've got a hotspot here. I'm going to spin up some stuff. Okay, we're done. This is cooled off. I'm going to spin it back down. So might be interesting. It's a function of time, though. I mean, if you've ever heard of the Cisco ACI product, that is basically SDN on steroids under the hood. That's all that it is. So it's definitely production worthy stuff. So it'll be very exciting. Any other questions? Sure.
I kind of had like a big picture question about the operations at the lab. A long time ago, when you had like a symmetric multiprocessor computer, and this might be more of an HPC question, but I know, recently the number of processors on individual machines has ballooned with the advent of multi-core processing. How has that changed the networking requirements at the lab? Or has it?
So that's a good question. So with respect to the networking side of the house, so I was playing around with a technology a few years ago called Viata, and Viata basically it was an open source routing thing. But what it would do under the hood is it would look at, you were limited by how much you could put through each core, right? So what Viata would do under the hood is it would actually spread that load across multiple cores. And so from a networking perspective, if you were using commodity hardware, you could actually take more advantage of your hardware by using that technology. Now, to be honest with you, on the HPC side of the house, I imagine there's probably similar things that goes on the application layer. I honestly couldn't speak for that.
This is to respond, Richard. Are you talking about single system image multi-processing where systems share CPU and RAM as if they were a single image?
Yeah, so some compute intensive applications will try, you can run, like the ones that I used to run, you could run them on a SMP machine, like where they did share memory and share computing processing. But like sometimes some of the applications, you know, it would be great if you could use 28 cores, but it would be even better if you could use 96 or 1000. And so when you have to communicate between the machines, then the throughput gets pretty high. I was just asking about how, you know, the change in the computer architecture may have changed the needs of the network between the computers.
So the answer, actually, I can say is, because I was looking at it yesterday and the day before, is that networking is capable of supporting that more now than ever, but no one is actually investigating it because people like Dell are now putting out 2 terabyte RAM 1Us with like 96 cores. I think even a company that was famous, ScaleMP, is now gone the way of the dodo. If you want to talk about it with me later, you can find me easily on the internet because I love SM signal. You know what I'm talking about, and we can talk about it.
Thank you, Mark. GPU friends are using multi 200 gig connections to connect groups of GPUs from machines to each other, so they can act as a much larger GPU player.
I mean, a lot of your computes, I mean, that's what, I mean, yes, when we shifted over from CPU intensive systems to GPU, I mean, Titan was mostly GPUs, right? It was only a very small portion of it was CPU. Summit, I mean, it was the same way, right? Has many GPUs. I mean, Frontier is no different. It's just, you have to think about the bottlenecks with respect to that, is how much bandwidth do you have between, and what is your latency from that? If it's the same GPU on the same server versus the GPU on other servers, right? So there's a function of bandwidth and latency with those.
Now that you can connect directly to the PCIe bus instead of more south bridges, it's much slower than it used to be.
Is, I mean, when you start thinking about the latest PCIe gen, it's just it's hard to fathom, right? It really is. But
So I remember when Intel, I believe, bought Cray or something like that. They were putting, someone was putting
Omnipath.
Dragonfly or something on the CPU itself.
You're thinking of that. Yeah, I know what you're talking about. It was the interconnect.
Yes.
Something to do with the internet. I thought that ultimately became Omnipath, which was bought by which Intel had, right?
Okay.
I think that was the earlier.
Did they just sell it?
They may have. That's yeah, the interconnects, that type of stuff is we're always going to have Ethernet, right? I mean, until we don't. But other stuff is going to always change. I mean,
so NVIDIA now has ASICs that talk directly between the CPU network, and AMD just bought that company. I forget what it's called. I'm sure Eric Mock knows what it is. That allows ASICs to talk directly to the CPU and then to the GPU and out.
It's involving Bitcoin, isn't it?
Nothing is involving Bitcoin.
yeah,
Hopefully Bitcoin is.
hopefully. You can actually buy GPUs now. So it's actually nice.
Yeah. I heard my name, but I didn't get most of it because the room mic just ain't quite there.
So I have a question. So this is a personal question meant to incite those fights later on.
I love it.
So IPv6 or just adding 3 octets to IPv4?
That sounds like a conversation for after.
That's a fist fight conversation.
I wouldn't call it fist fight. I would say that.
You'll have to wait till next month when I can be at the bar.
Yeah, that should definitely be done at the bar though.
Yeah.
Yeah, save that for the bar.
Are we done with like immediate questions? Well, hey.
Yeah.
Yeah.